Good morning. Today I'm going to talk about a minimization technique, one of the minimization techniques to simplify your Boolean expressions, that is your Kmaps. Kmaps called as corner maps. Here, if you have n variables, you will be representing these n variables in the locations. It's a graphical representation, so you will have 2 per n locations, or we call them as cells. Okay, so now see, if I have two variables, I will have 4 locations. If I have 3 variables, I'll be having 8 locations, and 4 variables, I will be having 16 locations. So we will see how can we minimize. Why do we require minimization techniques? I've already discussed. It will help you to simplify your circuit. Obviously, the cost, the heat dissipation, the power consumption, and all these are reduced when you minimize your expressions. Okay. So now how do we use this technique? Say for example, they have given us this function f of a comma b. This is a function of two variables, you can see, and these are the minterms. I've already discussed about the minterms and max terms. So say 0, 1, 2 are the minterms given to you. Now you are supposed to minimize this expression. So since this is a function of two variables, you will have only two literals and four locations. So the first one will always be a bar, because this what we are dealing is your SOP, sum of products, which I've already discussed with you. A bar A and B bar B. So this A bar is taken as 0 here and A as 1 in your minterm. Okay, this is 0, this is 1. So this will be 0, 0. So this location is 0. This will be 0, 1. So location is 1. This is 1, 0. So the location is 2. This is 1, 1. So the location is 3. Now you are supposed to lay down these min terms inside this map. So wherever you have a which are the min terms, for all these min terms you should mark a 1 in the K map. Okay, and for the missing min term, out of the 4 combinations what you should get, 3 is missing. So the missing min term becomes a max term. Max term is represented using 0. Okay, now after this, how do we minimize? We have to minimize by grouping the bits. So to group them, always the rule is the group size should be a power of 2. That is, if you have um, if you have to form the groups, it should be 2 per 0, that is a single group. Then 2 per 1, 2 literals are grouped together. 2 per 2, 4 literals are grouped together. 2 per 3, 8 literals are grouped together. 2 per 4, 16 literals are grouped together. So this is the group size, how you can group. Okay, so and the ones should be adjacent, they cannot be diagonal and all, they should be either horizontally or vertically adjacent. So now here I'll be getting two groups, as you all see. So this is one group. Okay, this is one group or subgroup we call. Okay, this is or subgroup. This is the second group. Here, see, though this one is grouped with this, for this one I can always group with this. So I'll get two groups. So for this the expression is A bar, because when we write the expression, actually it is A bar B bar plus A bar B. So if I remove the common variable is A bar, B bar plus B will go in, B bar plus B is 1, so you will be getting A bar. So that's why for simplified way of writing, what I suggest is you leave the variable which is changing, that is B bar and B is changing. So which is constant you take, A bar is constant here. Now if you come to the second group, okay, A bar and A, they are changing, which is constant B bar. So write down b bar. So the expression is f equal to a bar plus b bar. Okay, this is the expression. So this is for two variable expression. Similarly, we will see how to execute the same for three variables. For three variables, say for example, f of a comma b comma c equal to sigma min term of 0, 1, 5, 6, 7. These are the min terms given to me. Now, for three variable expression, you will have 8 locations as I've already told you. It is with the power of 2. Okay. So, these are the locations. So, if I take A here, if I take BC here, this becomes A bar, A, B bar, C bar, B bar, C, BC, BC bar. Okay. So here A bar, B bar, C bar, this is 0th location because A bar is 0, this is 1. And this I've already discussed with you why I wrote B bar, C bar, B bar, C, BC, BC bar. Instead of BC bar here, I've written BC. As you all know, we follow the gray code technique here because at each and every consecutive location, you need to ensure that there is a 1-bit change. If you write BC bar here, it is not consistent. So I have put BC here. So this is the gray code format which we have already discussed. So I think that is clear for you all. So in that case, if you take this location becomes 3 and this becomes 2 and this is 4, 5, 7 and 6. Now you're supposed to fill in the values. So wherever you have this min terms, you have to fill with 1. So I'm making all this locations 1, 6 and 7. The rest I'll mark with zeros because missing min terms are max terms. Now I should do the grouping. To do the grouping, okay, the one should be adjacent. So if you carefully examine this, you can form one here, one subgroup. The other group is this. Then I'm left with this one. I can either group with this one or I can group with this one. It is left to you. Anything. Okay. You can either go with this or with this group, but any one. Otherwise it becomes redundant. Okay. So totally I got 3 subgroups here. And here, see, always the rule is look for a small group, larger group, so that the number of literals are less. Okay, that is the rule. But here, the maximum group what we could form is a pair only. Okay, so now for the first variable, if you write the expression, what would it be? It would be a bar is constant and b bar is constant. So I'll get a bar, b bar. For this third group, if you write for this pair, it would be A and C. A, C. Then for the second group, it would be A and B. So I get the expression as F equal to A bar, B bar plus AC plus AB. This is one expression, or it would have been, if I would have considered this, the dotted group what I have put, okay, it would have been A bar, B bar plus B bar, C plus AB. Okay, so this is how it is done. Any one you can write. Next we will see for 4 variable expression. This I am dealing only with SOP now. Okay. Now, now for the fourth one, f of a comma b comma c comma d for four variables. Okay. Sigma mean term of 0, 1, 3, 4, 5, 7, 8, 10, 11, 13, 15. Something like this is given to you. These are the terms. So now you are supposed to, for four variables, you will have 16 locations. So now I'll draw the Kmap. I'll pick a different color. Okay. So I'll have how many locations? 16 locations. This is AB. This side it will be CD. So this would be A bar, B bar, A bar, B, AB, AB bar. How we did for three variables. This would be C bar, D bar, C bar, D, CD, CD bar. So now this location would be 0, 1, 3, 4, oh, I'm sorry, 2. This would be 4, 5, 7, 6. This you know how you will get, because this would be 0, 0. This would be 0, 1, because A bar is the complemented literal is taken as a bar, and the non that is, it is taken as 0 and the non complemented as 1. So this is 0, 1. This would be 1, 1. This would be 1, 0. Okay. Similarly here also. So going with that, this would be 8, 9, 11, 12. How 8 you see? 1, 0, 0, 0. Okay, like that. Then this is I'm sorry, 8, 9, 11, 10. This would be 12, 13, 15, 14. Okay. So now if I have to map the locations, I'll just write down here, so that because the cells are small there, I will write down here. So now this is 0th location. So 0, 1, 3, 4, 5, 7, 8, 10, 11, 13, 15. The rest are marked with zeros. So when you look, you can look for a larger group first. Here check whether you have the possibility for an octet. No, I don't have the possibility for octet. If I had 1 here, that is if 9 was 1, then I would have got. Now I don't have a possibility of an octet. The next group would be a quad. Okay, so we will see how we can do. So if I take this as one quad, okay, I have to consider this as the second quad. Change the color. The overlapping ones are fine. So here I have one more quad. Then here, see, I can have a quad here, but this one would be left out. So it's of no use. So I'll take this as a pair. Okay. Then this as another pair. So I will be getting these groups. Now we will write down. This is your A bar, B bar, A bar, A B, A B bar. This would be C bar, D bar, C bar, D, C, D, C, D bar. So this first quad, okay, what is the expression for this? This is the second one, this is the third one. So totally, or what you can do is you can take this as one quad only. Just a second, yeah, color is changed. My cursor. Yeah, this could be a pair only, quad only. I'll tell you why. Because this one is there, na? This I'm anyhow grouping with this. So this pair you can leave and you can consider this as a quad only. So I'll have 4 quads and one pair. Okay. So now we will write down the expressions for each one of them. For this, the expression would be A bar, which is constant, and here C bar. A bar, C bar. See, in a 4 variable expression, if you get a quad, it would be 2 variables what you will get. So you will get A bar, I'm sorry, this would be C bar. A bar, C bar. Next one would be A bar, D. Second one is A bar, D. The third pair would be B, B, D. B, D. And fourth one would be C, D. And fifth one is a pair. It would be pair, the row is constant, so it would be A, B bar. This column and this column I should consider, so the constant one is D bar. A, B bar, D bar. So the expression I'll write down here, the final expression, F equal to A bar C bar plus A bar D plus BD plus CD plus A B bar D bar. Okay, this is the final expression, or we call them as the essential prime implicants. All this, see, if I would have considered this pair also, all these become your prime implicants, and the required the essential minterms which are there, from that picked out. I've already discussed about the implicants, prime implicants and essential prime implicants. So this would be your final expression. So now if I have to represent this using only NAND gates, okay, so this is your expression. I'll be using the double rail logic. As you all are aware of the double rail logic, that is taking the literals in the complemented form directly without using an inverter. So next one is A bar D. Next one would be BD. BD. Next one would be CD. C and D. Next one would be A B bar D bar. A B bar D bar. So now you all know this will give you A bar C bar the whole bar, and going with this, if you apply your De Morgan's law, you will get the actual expression. I am considering multi-input NAND gate. So here you will be getting actual one, A bar C bar plus A bar D plus BD plus CD plus A B bar D bar. Okay, because this here you would have got A bar C bar the whole bar, A bar D the whole bar. Okay, like that. Going with that, BD the whole bar. This would be CD the whole bar. This would be A B bar D bar the whole bar. So again that complemented here you will get this. This is how you represent. Thank you all.